Hello everyone, welcome back to my channel. Let's solve third problem from super node analysis. Let's go for the problem now. So in this problem, they asked you to find the values of all the node voltages. Find all node voltages using nodal analysis. So now the same procedure. First you have to check whether is there any. First we need to check whether is there any super node is there or not. Obviously it is having one super node. So now I'll mark V reference is there. So I'm marking here V1 is here, and here V2 is there, and here V3 is there. So that there is a super node voltage 10 volts between the nodes V2 and V3. So that's super nodes V2 and V3. From that you need to write one equation. So I will write now V2 minus V3 minus 10 equals to 0. That is nothing but V2 minus V3 equals to 10. This is equation 1. Okay. So now the same steps at V1, assume the currents which are living. So I'm assuming here I1 is flowing here and 4 ampere is entering here and I2 is leaving, I3 is leaving and 8 ampere is entering. Similarly, so V2 and V3 are supernodes. At V3 you can assume I1 is entering, and at V2 you can assume I2 is entering, and I1, I2, I3, I4 which is living here, so this is I4. And again at V3 20 ampere is entering, and one more, that is I5. I'm assuming that which is leaving. At V1 total how many currents are there? I1 4, I2, I3 8. 1, 2, 3, 4, 5 currents are there. And at V2, I2 and I4 along with the supernode current. At V3, 1, 2, 3, 3 currents along with the supernode. So now let's define supernode. So what is supernode now? Supernode current equations, algebraic sum of all supernode currents equals to 0. So now I'll write what are the supernode at node V2. At V2 you assume I2 is entering, I4 is leaving. So that plus I2 minus I4. Again at V3 you was looking to the current at V3. I1 is entering, so that plus I1, I5 is leaving, so that minus I5, 20 ampere is entering, so that plus 20 amperes. So now algebraic sum of these will be 0. So that I will write it here now. I2 minus I4 plus I1 minus I5 plus 20 equals to 0. This is supernode current equation. So now we need to substitute the values of I2, I4, I1, I5. So I can give this as equation number A just for reference. Okay. So now write the current values. So I1 I will write now. So I1 which is flowing from V1 to V3. So that I will write it here I1. So I1 is nothing but tail end voltage is V1. See here I1 is flowing like this. This is I1. V1 minus V3 divided by 4. Tail end voltage minus air end voltage. V1 minus V3 divided by 4. Whereas we can rewrite here as 1 by 4 is nothing but 0.25. So that's 0.25 V1 minus 0.25 V3. Similarly, I2. See I2 which is flowing from V1 to V2. That's nothing but I2. We can write here as V1 minus V2 divided by, again you write here at I2, at V2, 4 ampere is leaving, sorry. So that minus 4 again here it is. So 20 minus 4 equals to 0. Forget to write at V2 supernode. So I2 is at V2, I2 is entering, I4 is entering, 4 ampere is leaving. So that minus 4 equals to 0. So now I2 we can write it as I2 is V1 minus V2 divided by 3. That's nothing but 1 by 3 is nothing but 0.334 V1 minus 0.334 V2. That is I2. Similarly, I3. See I3 which is flowing from V1 to reference. This is I3. So that you can write I3 is nothing but V1 divided by 2 is nothing but 0.5 V1. Similarly, I3 is finished, I1, I2, I3, I4. I4 which is flowing from V2 to reference. So that I4 equals V2 divided by 1 is nothing but V2 only. Next, I5 which is flowing from V3 to, this is I5, V3 to V reference. So that I5 equals V3 divided by 5. That's nothing but 0.2 V3. So I5 is finished. So I hope I wrote all the current equations. Now I wanted to substitute to this super node current equation I2 minus I4. So I'll rewrite here again. So before that you observe once again. So at V2 node, algebraic sum of all super node current equals to 0. At V2 node, observe the currents. 4 ampere is leaving, so that minus 4. And I2 is entering, so that plus I2. I4 is leaving, so that minus I4. Similarly, at V3, you also look into the V3. I1 is entering, so that plus I1. I5 is leaving, so that minus I5. 20 ampere is entering, so that plus 20. So that algebraic sum of these are nothing but I2 minus I4 plus I1 minus I5. 20 minus 4 is nothing but plus 16 equals to 0. So now substitute these values. The values are I2 is nothing but 0.334 V1 minus 0.334 V2 minus I4. I4 is nothing but V2 minus V2 plus I1, that is nothing but plus 0.25 V1 minus 0.25 V3 minus I5, that is nothing but minus 0.2 V3 plus 16 equals to 0. So V1 you can see 0.334 V1, 0.25 V1. So you can get 0.334 V1 plus 0.25 V1. You can get 0.584 V1. 0.584 V1. Similarly, V2 minus 0.334 minus V2, that is nothing but minus 1.334 V2. Then V3 minus 0.5 minus 2, 0.2, that is nothing but minus 0.45 V3 plus 16, else and right side it becomes minus 16. This is equation number 2. You already have equation 1, so now equation 2. So now from supernode you got one equation, from supernode currents you got one equation. So which means that from V2 you got equation, from V3 you got equation. So now we need to write from V1. So apply KCL at node V1. So look into here V1. 8 ampere is entering. See here 8 is entering. So that plus 8. Similarly I3 is leaving. So that minus I3. And I2 is leaving minus I2. And 4 ampere is entering. So that plus 4. Similarly I1 is leaving minus I1 equals to 0. So 8 4 12. 12 minus I3 is nothing but minus 0.5 V1 minus I2. I2 is nothing but minus 0.334 V1 plus 0.334 V2 minus I1 minus 0.25 V1 plus 0.25 V3 equals to 0. So now we can see 0.5 V1, 0.334 V1, 0.25 V1. That is nothing but 0.5 plus 0.334, 0.25. So you can get 1.084. 12 minus 1.084 V1. V2 only one is there, plus 0.334 V2, and V3 only one is there, plus 0.25 V3 equals to 0. I'll rearrange this. I can get 1.084 V1 minus 0.334 V2 minus 0.25 V3 equals to 12, and this is equation number 3. So now solve equation 1, 2, 3 with the help of calculator. You get the answer. Solve equation 1, 2, and 3. So that you can get the value of V1, V2, and V3. So now keep your calculator in equation mode. 3 unknowns. So V1 is 0, V2 is 1, V3 is minus 1, 10. Similarly, from equation 2, 0.584 minus 1.334 minus 0.45 minus 60, 1.084 minus 0.334 minus 0.25, 12. So you can get V1 is nothing but 18.156. Similarly, V2 will get 17.43 volts, and V3 you will get 7.44 volts. So these are the node voltages. So if you're having any doubts regarding this, feel free to write in the comment box. So I hope you're understanding the concept. If you really like this video, kindly do subscribe and share maximum. Thank you. Have a nice day.